Welcome to Cookie's Maths and Science Hub. In this video, you're learning about the basics of quadratics and how to factorize them. So, what is a quadratic? Quadratics are equations where the highest possible power is 2. Remembering that powers are our exponentials. So for example, x squared is a quadratic because it is x to the power of 2. Whereas x to the power of 3 or x cubed is a cubic. We write out our quadratic equations in the standard form of a multiplied by x squared plus b multiplied by x plus c, where a, b, and c are known numbers, and x is our unknown. We draw them on Cartesian planes as parabolas, which looks like the curve in the diagram here. Important parts of a quadratic are its roots, or x values, its y-intercept, where it crosses the y-axis, and its vertex, which is where that parabola turns around. We will be discussing how to factorize equations and draw equations in a number of different ways. But before we do this, it's important to know how to solve equations in our final step. We do this by using what's called the null factor law. This law states that if the product of two numbers is 0, then either or both of the two numbers is 0. For example, if we had a times b equals 0, then a would equal 0 or b would equal 0. Looking at some actual examples with numbers now, if we had 4 times a equals 0, because we have the 4, we must know that therefore a is equal to 0. One that's more common in our quadratics is something like this, where we'd have 5 plus q times a equals 0. Therefore, in this situation, either q is equal to negative 5, as if q is equal to negative 5, it makes that first part of the sum 0, or a is equal to 0 by itself. This next one is more of a standard form that you'll see for quadratics. We have 4 plus x multiplied by x take 7 equals 0. In this situation, we need one of those two terms, so either the first bracket set or the second bracket set to equal to 0. So, in this situation, therefore, either x is equal to negative 4, as 4 plus negative 4 gives 0, which would fulfill the null factor law, or x is equal to 7, as 7 subtract 7 is equal to 0. Either of those options are true for this equation. As was mentioned at the start of the video, the standard form of a quadratic is x squared plus bx plus c. To factorize quadratic equations, you need to find factors of c that add together to give b, and we'll call these factors y and z. So in this case, we would have x squared plus, in brackets, y plus z x plus yz equals x plus y multiplied by x plus z. Now I know this can sound confusing, but hopefully it'll make sense after we go through a few examples. So let's look at our first. We're asked to factorize x squared plus 7x plus 6. So we know our b value is equal to 7 and our c value is equal to 6. So looking at our factors of 6, we have 1, 2, 3, and 6. Now we need to pick two of these factors that add up to 7. Obviously they need to be a factored pair, so 2 and 3, 1 and 6. We know that 1 plus 6 equals 7. Straightforward, I know, but we need to double check. Therefore, our y value is 6 and our z value is 1. This gives us x squared plus 7x plus 6 factorized down into x plus 6 multiplied by x plus 1. Using null factor law, we can then solve from this stage as we set that equal to 0, and then we'll either have x equal to negative 6 to make that first bracket set 0, or x is equal to negative 1. Looking at a second example, we have x squared minus 4x minus 12. In this case, our b is equal to negative 4, and our c is equal to negative 12. It's important to remember to include the negatives. Our factors of negative 12 are 1, 2, 3, 4, 6, 12, and their negative pairs, -1, -2, -3, -4, -6, -12. When dealing with negatives, sometimes you'll have to do a bit of addition and subtraction to get to that B value. So in this case, looking through our different factors, can you have a go at seeing what will add up to -4? In this case, our Y value will equal -6 and our Z value will equal 2, as -6 plus 2 gives us -4, which is our B value. Therefore, we have x squared take 4x take 12 is equal to x subtract 6 multiplied by x plus 2. Now, in both the first problem and this one, you can then remultiply out to double check your answer, going through the process of multiplying each bracket against one another. Using our null factor law to finish this one off and solve for x, we have x subtract 6 multiplied by x plus 2 equals 0. Therefore, x will equal 6 or x will equal -2, as this will solve either bracket pair for 0. Okay, our next one is x squared plus 4x plus 4. So we have b is equal to 4 and c is equal to 4 in this case as well. Our factors of 4 are 1, 2, and 4. In this case, to get 4 just by itself, for that b value, we'll have y equals 2 and z equals 2. This will give us x squared plus 4x plus 4 is equal to x plus 2 multiplied by x plus 2. We can simplify that down further, as this is what's known as a perfect square. So we just have x plus 2 squared, as it's just itself multiplied against itself. Given that equal to 0, we can see that x is equal to -2. Our final example for these straightforward factorizations is x squared plus 8x subtract 9. So our b value is 8 and our c value is -9. Our factors of -9 are 1, 3, 9, and their negative pairs, -1, -3, -9. To get 8 by itself, we'd be looking for a 1 and a 9, and because it's positive, we'll have y equals 9, positive 9, and z equals -1. Therefore, we have x squared plus 8x subtract 9 equals x plus 9 multiplied by x minus 1. Applying the null factor law, we have x plus 9 multiplied by x minus 1 equals 0. Therefore, x equals -9 or x equals 1 to solve each bracket. Now, sometimes quadratics also have an a value, that is, a value in front of the x squared. For this process, you'll follow the following steps. You need to multiply your a and c value. You then find factors of ac, or a multiplied by c, that equal b. In this example, we'll also call these y and z. You then split bx and then factorize via grouping. So what I mean by split is, if you look below, we have ax squared plus y plus zx. So you split that b into the y plus z. Plus c is then equal to ax squared plus yx plus zx plus c. From there, you can factorize down into groups and then solve the equations. So let's look at some real examples, and hopefully that'll clear up any confusion. Our first one is 3x squared subtract 5x plus 2. So our a value equals 3 and our c value equals 2. Therefore, AC is equal to 6, remembering that AC is A multiplied by C. As we wish to get to -5, which is our B value in this equation, we will need to have Y is equal to -3 and Z is equal to -2. Remembering that negatives multiply together to give a positive. So -3 multiplied by -2 gives us our 6 value. We then write this out. So we have 3x squared subtract 5x plus 2 will now equal 3x squared subtract 3x subtract 2x plus 2. You'll see this is the exact same equation. We've just split it up further so we can then factorize much easier. Therefore, we have 3x multiplied by x take 1. As you can see here, in the first two steps of this equation, I have taken out 3x, as we had 3x squared take 3x. Taking 3x out of both of them leaves x minus 1 multiplied by that 3x. We then have subtract 2 multiplied by x take 1. So this is those final two steps of the equation where I have taken out negative 2. We had negative 2x plus 2. So taking out negative 2 from the first bit leaves x, and from the second bit leaves negative 1. Again, remembering two negatives make a positive. We then pull out the two different parts. So we pull out the 3x minus 2, and we put that in our first bracket, and the x minus 1 becomes our second bracket, because we had that 3x and that negative 2 multiplying x minus 1. So we are left with 3x minus 2 multiplied by x minus 1. Setting that equal to 0 once more, you would get x is equal to 2 over 3, or 2/3, or x is equal to 1. Okay, another example now. We have 13x squared, take 7x, take 6. So a equals 13, c equals negative 6. So our AC, our a multiplied by our c, equals negative 78. Now, for looking for factors that add up to 7, I would use a calculator for these ones and just have a bit of a play around with what works and equals negative 78. Hopefully, remembering that you need to equal that b value. So in this case, we'll end up with negative 13 for our y value and 6 for our z value, as negative 13 plus 6 gives our negative 7, which is our b value in this equation. And 13 multiplied by 6 gives 78, so negative 13 multiplied by 6 gives negative 78. So then rewriting our equation, we'll have 13x squared, subtract 13x, plus 6x, subtract 6. In those first two steps of that equation, 13x squared take 13x, we can take out 13x, and we're left with x minus 1. And in the second two steps, we have 6x minus 6. So we can take out 6, which just leaves us with x minus 1, which then simplifies down to 13x plus 6 multiplied by x subtract 1, because the 13x and the plus 6 are both multiplied by x minus 1, so we can group them together and separate out the x minus 1. Applying null factor law, we'd have x is equal to 6 over 13, or 6/13, or x is equal to 1. Okay, another example now. 2x squared plus 5x subtract 12. So we have a is equal to 2, c is equal to negative 12. So our AC, or a multiplied by c, is equal to negative 24. We then have y is equal to 8 and z is equal to negative 3, as 8 subtract 3 gives us our positive 5, which is our b value. Placing that back into the equation, we end up with 2x squared plus 8x, subtract 3x, subtract 12. That first two steps, 2x squared plus 8x, hopefully you can see we can take out 2x from both, leaving us with x plus 4, so 2x multiplied by x plus 4. And in the second two steps, well, 3 goes into 3x and 12, so we'll take out negative 3 in this case, and be left with x plus 4 as well. Combining those two parts of the equation now, we'd have 2x subtract 3 multiplied by x plus 4. Once more, to solve for that x value at the end, we apply the null factor law and are left with x is equal to 3 over 2, or x is equal to negative 4. Final example now for these ones. We have factorised 9x squared plus 9x subtract 10. So our a value is 9, our c value is negative 10, which makes AC, a multiplied by c, equal to negative 90. So therefore we have y is equal to negative 6, and z is equal to 15. Again, playing around with those bigger numbers in your calculator, and eventually you'll find some factors that are equivalent and add together to equal 9. So in this case, 15 subtract 6 gives us our 9 value. Writing out the equation with the changes, we have 9x squared plus 15x subtract 6x, take 10, which then groups down those first two parts being divisible by 3x, as 3x goes into 9x squared 3x times, and goes into 15x 5 times. So we had 3x multiplied by 3x plus 5. We then have 6x subtract 10. We can see that 2 goes into both of those, leaving us with negative 2 multiplied by 3x plus 5. Grouping them back together, we have 3x subtract 2 is multiplied by 3x plus 5. Applying null factor to finish off, we have x is equal to 2 over 3, or x is equal to negative 5 over 3. Thanks for watching. Hopefully you now know the basics of quadratics and how to factorize them, as well as solving them using the null factor law.